In this video, we are going to discuss the fourth theorem's proof in circle geometry grade 11 and 12. Alright, so before we can discuss the proof, let's just discuss what actually happens in this theorem. Alright, so theorem 4, they provide a cyclic quad, so they would provide the quad, and if we read there, P, Q, R, S. How do we know it is a cyclic quad? Because it has 4 points on the circumference of a circle, forming a cyclic quad. Now, our conclusion then, based on theorem 4, would be angles P plus angle R, the opposite angles, are supplementary. And so P plus R equals 180, and S plus Q is also supplementary. Alrighty. Now, the question that you're going to be provided in the actual proof, they would say prove that, and then they're going to give you two angles opposite each other, and they're going to say prove that if you add them together, it equals 180. In other words, they are supplementary. Alright, now when it comes to the proofs in circle geometry, please remember one very important thing. Constructions. It is so important for you to construct what you are going to use for the proof. So let's just put this dramatic bubble over there. Your first step is you need to say construct. And now you're going to write something down. That's for all proofs. Alright, now for this specific proof, what we need to see is we need to use something to show that angle R plus angle P would equal 180 degrees. And we have a really cool tool in our arsenal, or in our toolbox, known as theorem 2. Alright, so if I make a construction with theorem 2 in mind, what I'm going to construct are lines or radii OS and OQ. And what that would look like would be, well, we need to find the center point of that circle, and then we're going to draw lines from there. And now we need to label the center O. So yes, you can go and find the center in your question paper if it's not given, and you draw a little construction to the other two corners in the cyclic quad. And now, remember, we are thinking theorem 2. Now we can go look at the angle at the center versus the angle at the circumference. I'm just going to label this O1 and O2. O2 being from that line to that line. Alright, so theorem 2 in mind. That is our cheat code here. Theorem 2 in mind, we are going to classify O1 and O2. So angle O1 would equal 2 times angle P. Let's take a look at that. O1 would equal 2 times angle P. If you're unsure, please go take a look at the roadmap video on the whiteboard tutoring. It helps you understand the theorems a lot better. Alright, so we have O1 equals 2 times angle P, and our reason there is angle at center, not centri, center, equals 2 times angle at circumference. Okay. And what else can we say? Well, we can also classify O2, and we can say, well, that is 2 times angle R. Same reason. Angle at center equals 2 times angle at circumference. Alright. And what we can say now is, if we add O1 and O2 together, what's going to happen there? So O1 plus O2 equals what? Adding these two together, we see its angles around a point. It'll equal 360 degrees. So O1 plus O2 equals 360 degrees. And that is angles round a point. Alright? And we know that angle O1 plus angle O2 would equal 2 angle P plus 2 angle R. Okay. And why would O1 plus O2 equals 2P plus 2R? Well, let's take a look at the statement. If A equals X and B equals Y, well then A plus B would equal X plus Y. It's the same thing. Alright, but we know that O1 plus O2 equals 360, right? So that's 360 degrees equals 2 angle P plus 2 angle R. The cool thing here is you just divide everything by 2 to get P and R alone, and what that is 180 degrees equals P plus R. Alright, let's try it in another way. Alright, let's look at this one nice and quickly. So now they're going to say prove that, and now they want to show that the other two angles, S and Q, are supplementary. In other words, angle S plus angle Q equals 180 degrees. And what's our first step? Remember the dramatic bubble? We need to construct. So we're going to construct radii OP and OR, and we need to write that step down. It counts marks. Construct radii OP and OR, and that's what we did there. And now we're going to look in the two different triangles, or we are going to use our cool tool, theorem 2. Alright, very, very, very important. I know a lot of you want to use in triangle and triangle like we did in theorem 1. No, we are focusing on angles O1 and O2, so remember to label them. So let's express it. We can say O1 equals O2 equals. Alright, so O1 is going to be 2 times angle Q, and O2 is going to be 2 times angle S. Why? Because angle at center equals 2 times angle at circumference. I just wrote that down with lightning speed. Alright, so now we go back to the point O1 plus O2 equals 360 degrees. Y angles round a point. Okay, cool. But then O1 was so O1 plus O2 was equals to, you write S plus Q. Just want to make this a little neater. Okay, yes. Angle S plus angle Q. That is a plus. Sorry, that was bugging me. And we don't have to write a reason for that, but what we do need to say now is 360 degrees was equals to angle S plus angles Q. And it's not just S, it was 2S. Thank you for correcting me, whoever said what happened to the 2's there. Alright, and now we go and we say, okay, cool, divide everything by 2, so 180 degrees would equals angle S plus angle Q. And there you have it. Ladies and gentlemen, thank you so much for watching. I hope you have a fantastic day, and please remember to like, subscribe and share and become part of the whiteboard family. Again, if you struggled remembering what theorem 2 was and how it worked, please go take a look at the video in the bottom left corner.